2 through 22, is that what we did? Number 2 is yes, because the common difference is 5. Okay. Number 4 is 14, 18, 22. Number 6 is a sub n equals 0.5 n minus 1.5. 8 is yes, because the common difference is 4. 10 is no, because there is no common difference. 12 is 4.26, 5.32, 6.38. 14 is 13, 11, 9. 16 is 3 and 2/3, 4, 4 and 1/3. 18 is a sub n equals negative 5n plus 2. 20 is a sub n equals negative 4n minus 7. 22a is a of n equals 2n. And 22b is a graph, and I'll put a little sketch of it, a rough sketch on the board so you can see if you're on the right track or not, and we may need to look at it or whatever else. 22b. What?
It wasn't in the middle. I mean, it's at the very end of the problem. So you kind of just had to pull
Depressing.
I didn't finish it.
Depressing.
I'm gonna finish it.
You didn't.
I'm sad.
You got what?
I got
3, 5, number 20. Is that what it is? 22b is dots going up. Quadrant 1 only, and they go. And we can get more specific than that if we have a question about it. I don't know anything about skibbities or sigmas, so can't answer that. You're not going to beat me up. You're illegal. Okay, what questions do we have?
I was confused on 18 through 22.
So 18, right?
How do you do 12 next?
Probably.
Because I just said yes or no because
It says find the next 3 terms of each arithmetic sequence.
yes.
So they're all yes.
No, they're not all yes.
Yeah, they are actually. So if you got one that's no, you probably have a question on that one.
Oh, right. Yeah.
Okay, number 18
I have no idea.
is negative 3, negative 8, negative 8, negative 12, negative, 13, 18, yeah.
I forgot to do 6.
Because math.
Again, I'm so mad.
And the instructions say to write an equation for the nth term of the arithmetic sequence, then graph the first 5 terms in the sequence. 5 terms, not the function, which is why the graphs are dots and not lines. But we'll look at this one and get there. Okay, so 18. So how do we make the equation? What are our steps?
We do the add.
Find the difference between each one of them. So like negative 8 minus negative 3.
Mm-hmm. So what's the difference? Common difference. Negative 5. Okay. Then what do we have to do?
We have to get the 0.
Yeah, I get the 0th term, right? So we got to go backwards 1.
Add 5.
So we got to add 5. So what's negative 3 plus 5? It's not 1, it's 2, right? So, sure, totally did. You totally said it. Or something.
Why would you go backward instead of forward if it said the first 5? Does it always start at 0?
So these are the first 4, actually. What do
Did
you?
it say first 4?
It says graph the first 5.
Okay. Got it.
But we got it, because this gets us where it's like where it is at the y-axis, right?
Yeah, that makes sense.
Yeah. So now how do we write the equation?
It's like
How about a sub n, right? Equals what?
2.
Not the 2.
Negative 5n.
Negative 5n. Because that's our slope, right? That's what we're basically finding there.
Plus negative 3.
No, plus the 2. We're the 0 one. Okay, plus the 2. Okay, so that's the equation. Okay, and then we're supposed to graph the first 5. Kind of made a mess, but it'll be fine. You're traumatizing. Not really, though. Not really, though. I am sure you're not traumatizing. You might be traumatized, but not traumatizing. Okay, so first one is at 1, negative 3. 1, negative 3. Next one is at 2, negative 8. So here, and then 3, negative 13. 1, 2, 3, 4, 5. And then at 4, negative 18. 1, 2, 3, 4, 5. And then at 5, negative 21. 1, 2, 3, 4. Mm-hmm.
I was confused because on the homework it
Uh-huh.
had like it was 203 term.
203rd term. Mm-hmm. Yeah, those are a different problem. Oh, in the notes, find the blank term. Yeah, that's another different type of problem.
N
What?
term.
So like if we were asked to find the 532nd term of the sequence, we'd put 532 right there. I like to change the subscript over here, so this is the 532nd term, and then we put 532 in there, and then we multiply and add 2, and it'll give us that term. Mm-hmm. Okay. What other questions do we have? There was one, I think, which one did you have no on? Because we should look at that one.
16.
16, yeah, I thought it was going to be 16. All right, what was my guess? All right. All right. So 16 gives us page 1. Did we do one lesson or 2? Oh yeah, because there's only one left. That's right. Number 16.
I'm actually happy.
We're given the sequence 2, 1/3, 2 2/3, 3, 3 1/3. And we are supposed to find the next 3 terms of each arithmetic sequence. So it already tells us it's an arithmetic sequence. So there is a common difference. What is the common difference? 1/3. So it's adding a third each time. Third plus 1/3. Okay, so we need to add a third. So what's 3 1/3 plus a third? 3 2/3. And then add a third again. We get 4. And then we add a third again. And what do we get? 4 1/3. So that's what we do. Does that make sense? You just got to read the instructions good. You don't get it or you do get it? Okay. I know you didn't get any of those right. That's fine. But do you understand how to get them right? Good. Just didn't read the instructions good. Yeah, and the fractions were scary. I know. No one knows fractions. What other questions do we have? 22. Shiloh and her friends spent a day at an amusement park. In the first hour, they rode 2 rides. After 2 hours, they had ridden 4 rides. They had ridden 6 rides after 3 hours. Write a function to represent the arithmetic sequence. So, what should we do? Not a graph. You might mean the right thing, but not a graph.
Chart.
Yeah, a table. Yeah, I know. I thought that was what you meant to begin with, but. Okay, so time. And rides. The book likes to write their charts horizontally. I like to write my charts vertically, but you can do it however you want to do it. Doesn't matter, right? So it tells us after 2 hours, they'd ridden 4 rides. After 4 hours, they'd ridden 6 rides, is that right? Yeah. 6 rides, and after 6 hours, they'd ridden, 8 rides, right?
I just read it wrong because I thought 1 hour was 2 rides, 2 hours.
Ah.
4 rides, 3 hours.
Do we have any quizzes in there?
So that's probably why I got it wrong.
So, what do we do?
See what you
I kind of think the key might be wrong.
Right, turn around.
Were you learning how to do magic tricks?
No, I was. Bro, stop. I'm trying to. I got text. I was looking at it.
I see.
You wrote it wrong, I
What?
think.
So your ringtone?
It's, after
No.
first hour, 2 rides, after second hour, 4 rides,
Ah,
3 rides, 6
So I
rides.
did do it right. But
There we
it's
go.
the wrong answer, so.
okay.
Okay.
So I thought I read 3 at some point. I was confused. So 1, 2, 3. Is that right?
2, 4, 6 on rides.
1 hour was 2 rides.
1 hour was 2 rides
Don't worry. 4, 2.
and 6 rides. Great.
There we go.
There we go.
Fine.
That seems like a pre-algebra problem, but it seems like an algebra 1 problem.
What?
What?
Huh?
What
Huh?
do you mean, what?
I don't know. Did we finish?
did we write an equation? Put your phone away. Give me your phone.
Okay.
You're too distracted. It's distracting you.
Distracted. I just.
Somebody sending you a text. Probably Ridley.
No, it's Jack.
Mm.
He sent me a video. I said, I'm in math.
Yeah, we have to tell Jack to shut up. But first, let's just turn it on mute. Okay, great.
Wait, you do that?
There we go.
Yay.
Wait, you can do that?
I know how to do that, but how do
It's
you-
usually the other way around. The child knows more about phones than the adult.
I know how to do it, but
You didn't know I could do it with from the lock screen.
Hey, Drew,
Yeah.
more superior to that part.
Right.
What do we do?
Find the difference.
Great.
it's like 2 is the difference, y'all.
And then we subtract 2 to get the 0, and we end up with 0, right? So now what's what's the equation?
It's
And
Uh-huh.
equals negative 2.
Not negative 2. So it's the difference times n, and then plus the 0th term. So plus 0, so we can leave it off on this one, right? So it's just 2n. It's the forwards, not the backwards. Does that make sense? Good.
Plus 0?
You can put the plus 0 if you want, or you can just leave it off because it's plus 0.
right.
I know how to do that.
So that's the answer to A, right? That's all it's asking for. Great. And then part B, we're supposed to graph the function and determine the domain and range. How do they write the domain and range? Because I would write it one way, but I'm wondering if they write it a different way. Let's find out. Oh, when I was young.
Is
Yeah.
they like sick?
I don't know. I might have known and forgot, or I might not know. I don't know.
Or we just think.
Okay, yeah, they do write the domain. I don't know that I agree with this problem and the way they're interpreting it, but it's fine. Because it's not like they just like skip time and like jump to from 1 hour to 2 hours to 3. There's like time in between. And they're riding 2 hours, 2 rides. So like, I guess it's not strictly linear because you can't ride half a ride.
Right.
Well, it is linear, so I don't know. It's just kind of strange. Anyway, so do what?
I mean, if you just went on a Ferris wheel and then jumped when you got to the top, would that be half a ride?
Well, and you are on the ride, so while you are riding the ride, it's like half of a ride. So I think, I mean, I would make the case that you would actually draw a line and not discrete dots.
Every half hour, a ride.
Well, maybe. We don't have enough information to be sure about that.
Exactly.
So,
But isn't like Ferris wheels where you get like 2 rounds?
You go
well,
around,
it depends.
You go around once, like with it stopping, and then you go around one full way.
So twice.
So twice.
So if you
Yes.
get out
Precisely.
the first round,
But-
then that
This is like if this is the bottom of the Ferris wheel and then this is the top. Why does it go here and then you jump off and get to the top?
Shush.
all right, so after 1 hour, 2 rides, so this would be time, the time axis. This would be the rides axis. Okay. And after 2 hours, they rode 4 rides. 3 hours, they rode 6. We can assume that if they rode 4, they would get to 8. And 5 hours rides, they'd be puking their guts out, but they'd be at 10 rides. Actually, at the frequency they're riding the rides, maybe they wouldn't be puking their guts out. That's why they're only riding 2 rides per hour, because they're pacing themselves well. Or maybe they're really long rides, which again, puking their guts out. So, or long, well, that's true. They could be at Thief Flags or Disney Robber. Okay, so there's that. And then we're also asked to write the domain and range. So what's the domain of this function, this situation? What does domain mean?
domain is the X.
Yes, it's the list of all possible x's. So in this situation, the way we're writing it being discrete, that's it. We have to have just whole numbers. So you can't just list this to this. So you'd say 1, 2, 3, 4, etc. Right? We use the curly braces because that's just set notation. It says it's all those things. If you didn't put that on a test, I probably wouldn't count off for it. But using the curly braces is the right way to do it. What would the range be?
2, 4, 6, 8.
Etc. Yeah, that's right. 2, 4, 6, 8. And this kind of like informal, kind of abbreviated notation. That's how we say it keeps on going, right? It's just ellipsis marks.
So when you said if you don't do it, then I would probably count it off.
I was talking about the curly braces part, yeah.
I thought you meant like the whole domain and range.
No.
Like, what?
I would count off if it asked for domain and range and you didn't put it. That I would do. No. But in Algebra 1, I probably would not count off if you didn't put the curly braces. You probably want to try to get in the habit of doing it for the future, but I probably wouldn't count off for it.
So curly braces are for determining domain and range? Is it like
It's for writing any sets of numbers. It doesn't have to be specifically domain and range sets.
any sets of numbers?
Yes, it's kind of getting you towards set notation. So like in pre-cal, you can learn it in Algebra 2, but I don't teach it until pre-cal. We use interval notation mostly pre-cal. Like in pre-cal, if I was to write the domain of this situation, I would write this. I would write, all right, we're using time, so I would put time such that time is greater than or equal to 1. Time is an element of the integers.
No.
So I would do all that in pre-cal. So this is kind of like a baby way of walking towards
I don't like
doing all that. It's not, that's actually much less scary than it looks. That's what this means is what this, well, I am going to sort of describe it right now, and then we're going to do the other questions. But are you wanting to use this on the test? If you use it wrong, I'm going to count off. So it's saying this is the independent variable, the domain, right? And this pipe symbol means such that. So, and then this is the condition. So it's greater than or equal to 1. And then this tells us that it's a member of integers, so it's not all the real numbers. It doesn't. That's how we get the dots in here. Integer. There's symbols for real numbers, integers, rational numbers, all those things. What?
So I will use it in my test, but
If you try to use it on your test and you use it wrong, I will count off. So I would, not do that. But that's up to you. You have been warned. Okay. Finish. Go ahead.
I'll do that the normal way and then try to
Just write it on the side. That's fine. Yeah. Just make sure you circle this one. Any other questions? Okay. Well, normally I would practice. Y'all probably want to start looking at your study guide and the practice test. That's a good idea to do right now.
Are we doing a quiz?
We're not doing a quiz. I'm going to work on making a key. If y'all start working on the study guide and practice test right now, which is my recommendation, and you have questions all along the way, hit me up, bro.
What page is it?
It's at the end of chapter 3.